if you were to think about the overall workflow in your ML pipeline of like, how do I improve my data set? It is fairly simple, I would say. I heard this quote, how do you solve a problem? You look at the problem, you think really hard about it, and you write down the solution. And in this case, when you want to work on your data, go find the problems in your data. Like what's wrong with your data quality, or where are the places where your model is not doing well on your like training or production data. And then once you find those problems, like figure out why are those problems happening? Is it a reason of the data quality being bad, or is it a reason where the model is just not seeing a certain example that is very rare and doesn't know how to treat it? And then go and fix those problems. Either edit the data set, remove bad data, add in more data, the things that you want the model to get better at. And then as you retrain your new model on the new data set, you don't even need to change the code on the model. Make sure that this new model it produces is indeed better than the previous model, not only on the aggregate in terms of performance metrics, but also on the specific problems that you identified in the first step. And then once you do that, you repeat and you just keep cycling to make sure that you produce better models as you go through this loop. So when you think about the type of problems that you can encounter when it comes to your data set, there's a few different varieties of it. One of them is that your data itself is bad. When you're dealing with, for example, a physical process like a physical camera that has captured data, sometimes the camera can just like mess up, have a hardware error, and produce like distorted imagery or something like that. That's what you can see on this top right side as an example. And that's obviously something you probably don't want your model to be dealing with. You probably want to filter it out on the firmware side or something. Another sort of example is like when you have labeling ambiguities in your data set, or if you have labeling errors in your data set, the model will just like see different ways the same scenario is treated and it will not know what to do. Or even worse, you basically evaluate your model on your evaluation data set, and the evaluation data set is full of errors. And so the metrics are not trustable, which means that you're making bad decisions based on bad data, and therefore like you're going to go the wrong way. So on this right side, you can see an example where this is one of Andrew Ng's talks where you have different defects in the sheet. Do you label them as like one giant box over all the defects, which is what labeler 1 has chosen to do, or do you label each of the little defects individually, which is what labeler 2 has chosen to do? And this sort of ambiguity can confuse the model. It can cause it to make errors and mess up its performance. Another example, it's very common, difficult edge cases. This is when your model encounters a case that's just hard. If you study for a test and there's a topic on that test that you just don't really know that well, you're probably going to want to study more for it. And in these sort of cases, this could be like, for example, in imagery, like a very dark area or low contrast area. In audio, it could be like a lot of noise in the background. These are cases where the model legitimately struggles, and you just want to be able to collect more data so that the model can learn to get better at it. And then the last category of stuff is out of sample data, which is the model has never seen it before. It doesn't know how to handle it in production because it was never trained on anything like that. And so these are the common things that you can basically look for and solve when it comes to improving your data set.